happens if I have cosine negative x? What happens to the negative? We have two choices. It disappears or it gets pulled out in front. Yeah. What would you, I didn't hear. It cancels out. Because cosine negative x is the same thing as cosine of x. So this is just going to be cosine x on top. For sine, either we cancel out the negative sign, like we did with cosine, or it comes out front. Who could tell me what happens with sine of negative x? Charlie? I put the negative sign out front. So we have negative sine of x minus, well, we already said cosine, the negative sign disappears if it's inside, because cosine negative x is the exact same thing as cosine of x. There's no negatives in here, so it's just sine of x. So we could either simplify here. Well, let's just go ahead and simplify right here. What is cosine divided by sine? What's another way I can write that that's easier? Yeah, cotangent. So I can rewrite this as negative cotangent x minus cotangent x, which is just going to equal negative 2 cotangent x. And we're done, because anything else I try to do to it, if I try turning it into a tangent, I'm going to throw a fraction in there. And this is way more simple than having a fraction in there. Okay, that's the simplest form. All right, so you should have, after doing the homework, been able to do this. Figure out what happens with the negative signs. Simplifying is going to take a little bit of practice. Today, we're basically going to go over just some tricks to simplifying. I think you're only going to use this one once on the homework, and that's at the very end. I added another problem on it. I don't think you actually have to use this one on the homework. In fact, I'm pretty certain you don't have to use the next one on the homework. I just want to show it to you because when we get to more complex ones, it's going to save me time that we went over it once, that going over it again, we'll be like, oh yeah, now I remember doing that in class. Okay, so I'm just saving time when we get to the more complicated stuff. Before I even get to that, I handed out a trig sheet. We can't use this on the test, but a good idea is to keep this in if you have a binder, like in that front part, so you can pull it out really quickly. That way you're not flipping to that page with the identities on it. It'll make your life a little easier. I can make another copy for you. If you lose it, just let me know. This is just a rough idea of what we're going to be doing each day. I don't even have homework on it or anything. It's just a rough idea of what we're going to do. So based on this plan, we're going to have a test next Friday. Things can change, though. If I feel like you guys don't get it at all, we can always push it back a little bit. All right, but that's my immediate plan, because we only have a couple sections to get through. All right, that being said, I also want to cover real quick, any questions from the homework that was due today? All right, so if you see something like this, these are kind of last resort things. You're going to want to simplify stuff as much as you can. Say I had other stuff going on up here that I could simplify, I would do that first before I would do this step. So I can't simplify this any further. 1 plus sine, that's not an identity I have. 1 minus sine, that's not an identity I have either. I need a square in it to use the Pythagorean theorems that we have. So what it tells me is I need to do something else, because obviously that isn't simplified. I need a little bit of room because I'm going to write it a little bigger. Just going to get rid of that real quick. I need to wash my screen. Okay, so what we're going to do, if we get to two fractions, and there's nothing I can do to simplify any further, once again, last resort, don't try to do on your homework as your very first step, because a lot of them simplify way easier than this, but last resort, to add fractions, the denominators must be the same. So we'll have to create common denominators. To do that, I am going to take this denominator and multiply it by everything over here. I'm going to take this denominator and multiply it by everything over here. And that's all you need to know. All right, any questions? Comments, concerns? Should I do it? Okay. So we're going to take this denominator, 1 minus sine of theta. All right, so we're going to have 1 minus sine theta, and I'm going to put 1 minus sine theta. That just equals 1, right? Something over itself is 1. I am going to multiply it by the other fraction, the fraction I did not take the denominator from. So I'm going to multiply that by 1 plus sine theta. Okay, so I'm done with that fraction. For my next one, do you guys have a question? You sure? Let's focus on this.
Yeah, I was just saying, isn't the denominator just cosine squared theta?
No.
That's not how it's gonna work.
Oh, it might. When we do, yes, it will work out that way. Yes.
Okay.
Yep. Plus, then we're going to use the denominator from the other one. So we'll have 1 plus sine of theta over 1. I should do it in red like I did the other one. 1 plus sine of theta over 1 plus sine of theta. And we're going to multiply that by the fraction I didn't take it from the denominator. So that would be 1 over 1 minus sine of theta. All right, but you still know how to do this, whether you can see the answer or not. This is an important thing. It's just an easy problem that you can probably look past. All right, if I do all of those multiplications, we're going to have, well, 1 minus sine theta times 1 is just 1 minus sine theta. And that's going to be all over 1 minus sine theta times 1 plus sine theta. And that's going to be plus, well, 1 plus sine theta times 1 is 1 plus sine theta, all over 1 plus sine theta times 1 minus sine theta. All right, and if we notice, these are the exact same denominators. All right, because multiplication I can always switch. Using the commutative property, I can switch them. So we really have the same denominator. So we can rewrite this as, let's do everything. So we're going to have 1 minus sine theta plus 1 plus sine theta. And that's going to be all over. Let's do the multiplication. Well, it's a difference of squares, just like we did in the homework. Yeah?
It would be 1 minus sine squared theta.
Yep. It'd be 1, well, it's 1 squared if we could think in our head. But I wouldn't say it unless I was teaching, which I am. So it's really 1 squared, which is 1 minus sine squared theta. Well, our signs on top are going to cancel out. And Peyton, what's on the bottom going to be? You already told me.
Yeah, isn't it the cosine squared
Yep.
theta?
It's going to be cosine squared theta. This is simplifiable a little bit further. Because we have a 2 up here, right? But I could pull that 2 out front and say it's 2 times 1 over cosine squared. And what trig function is 1 over cosine? It's the reciprocal of cosine. That's the hint to you. The hint is it's the reciprocal. Callie? Secant. So in fact, this is going to equal 2 times secant squared theta. That's the full simplified version. This isn't quite simplified. Because normally when you simplify it, you won't have any fractions left. All right? That's always a good sign that you're done. You got rid of all the fractions. All right? Don't introduce new fractions either. Don't go, oh, I'm going to simplify this again and say it's cosine. Well, that's throwing in a fraction. Okay? Simplified, done. Questions? Like I said, I think there's only one example that you actually have to do this in the homework, and I think it's the one I added onto it. What was that? Nope. Okay. It's a good thing I'm recording this one. Yeah.
Question about the next, like just looking at the next problem.
Okay.
Couldn't you, the 1 minus sine of y, couldn't you just turn that into like just cosine of y?
Be careful.
I know it doesn't have a square, but it's a...
You can't unless it has a square. Good? So a really good question was asked is, can I turn 1 minus sine into cosine? It doesn't work unless they're squares. All right, so if you don't see a square somewhere in it, you're not going to use the Pythagorean theorems, okay? Yeah?
Question relating back to the last problem. So, can you flip it?
Okay, so we have cosine squared y over 1 minus sine y. Note again, it's not sine squared, so I can't use the Pythagorean right now. And I'm going to look at that, and I can't simplify it any further. Once again, this is kind of our last resort thing to do, because a lot of times we'll be able to simplify this, stuff will cancel out, and I won't even have to deal with the fraction. That's how a lot of these are set up. So in the homework, it might look like you have to do this trick. You won't have to. Simplify the top or the bottom first, and then see from there if you can't go any further. So I can't really simplify cosine squared any further because there's no 1 attached to it. 1 minus sine y, I can't use the Pythagorean stuff because there's no square. So it's going to tell me I can't do anything else, but I have this stupid fraction here. All right, so we need to get rid of it. So what we're going to do as the last resort is we're going to multiply by the conjugate of the denominator. What that means is if I have 1 minus sine, I'm going to multiply the top and bottom by 1 plus sine. So that'll be the top and bottom. So once again, this is one of our last resorts. This is, I'm all out of tricks. I'm going to try one last ditch effort by multiplying by the conjugate before I just quit and yell at Mr. Pavian. All right, so we're going to multiply by the conjugate, which would be 1 plus sine of y over 1 plus sine of y. And that's going to be multiplied by just our original one, that cosine squared y, 1 minus sine y. And so on top, I'm going to have 1, leave it in parentheses. You'll see why I'm leaving it in parentheses. And that's going to be all over. We'll have 1 plus sine y times 1 minus sine y. Difference of squares, what's the denominator going to equal? Don't go all the way, just, I don't know how to specify. Just tell me what you think the bottom's going to be. Without cosine in it, yeah.
1 minus sine squared y.
Yep, 1 minus sine squared y, which is the same thing as saying I'm still not going to distribute it because I know there's going to be a cosine on the bottom, so things might cancel out. So I'm going to leave that cosine alone. And on the bottom, that's going to equal cosine squared y. That is going to cancel out, and I'm going to have 1 plus sine y. Two things tell me that's as simplified as it's going to get. Do I have a square here? No, and it's also 1 plus. It would have been 1 minus if I could have changed it to cosine. So that's as far as I can go. I don't have any identities that say, hey, if 1 plus sine equals, I have nothing that says that. I have stuff that are squares and I have fractions, like 1 over sine is going to be cosecant. So that's done. That is it. Sometimes they won't be fully simplified where it's just one thing. It might be 1 plus or 2 plus. Okay? So that's why I said this is a good chapter to make sure you check your answers, because you might go all the way and you think you're done, but it might actually have one more step to it that you missed. Okay, questions on this one at all? Good. I'll leave it up for a couple more seconds. I see some people still feverishly writing. I'm looking for, and I'm hoping you guys look for it, is which identity has cosecant and cotangent already in it that I wouldn't have to change anything. 2 people. Nice. Nice. 3 people can read. We are crushing it today. Is it just this aisle that? JP, which one has cosecant and cotangent?
1 plus cotangent squared x equals cosecant squared x.
Boom, has cosecant and cotangent in it. I didn't say I was looking for it to the 4th, because none of them have it to the 4th. I'm just looking for one that has a cotangent and a cosecant in it, and I'm going to try to force it in that box. All right, so the trick we have to remember is that difference of squares. In other words, that x squared minus not plus, minus y squared. That is going to equal x minus y times x plus y. And you're like, Mr. Paving, that doesn't look like it's a square. It looks like to the fourth. But we can do the exact same thing. Because x times x gives me x squared. Well, cosecant squared times cosecant squared is going to be cosecant to the fourth. So we can rewrite this using difference of squares, and we're going to write it cosecant squared x minus cotangent squared x times cosecant squared x plus cotangent squared x. Okay, so now we're going to go back to that identity that we found. We said I had one that had squares in it and it has cotangent and cosecant. Well, I'm looking for, only one of these are going to be possible. Only one of these are going to actually be possible. So all we're going to do is we're going to see that cosecant is positive and neither one of them have a 1 in it. So I'm going to take that cotangent squared x equals cosecant squared x, and I need a positive cosecant, right? So I'm going to leave that alone, because as soon as I bring this to the other side, it makes it negative. I want this alone. So the only thing I can do is I can move the cotangent to this side. So I could rewrite this by subtracting cotangent squared from both sides. I could have 1 equals cosecant squared x minus cotangent squared x. So you should have room in your box to even write all that stuff. So this goes back to a point really quick that Peyton brought up. Am I going to give you those sheets on the test? And I will not. I will not, because it boils down to the fact that you should know all of these. You should know all of these. The only thing that was really new was this section, which, like I said, you just have to kind of remember the cosine secant 1 is different. And you should know this one already. The only thing you really have to memorize are these two. And then it just goes to the fact of, I wouldn't memorize these at all. I would just memorize these 3. And as soon as I get down to cosecant, cotangent, I would just force this thing to look like what I was trying to look for. Okay, so if I was taking this test, as soon as I got it, I'd probably write these 3 on the top. I might, if I kind of struggle with some of these, put some of these up, and I might put these up, but I would definitely have these on the top of my test. So when I get to that section, I can just kind of flip back and manipulate them the way I want. All right, so have those memorized. They'll make your life a lot easier. Tangent squared. So I look for the cosecant squared minus cotangent. That is that guy. So that guy's just going to turn to 1, right? So we really have 1 times cosecant squared x plus cotangent squared x. And so that just equals cosecant squared x plus cotangent squared x. And in fact, we're done. There's no way to further simplify this, because I don't want to change this into tangent, because that's 1 over tangent. That's introducing fractions. Yeah?
Couldn't you change the cosecant into cotangent and add them together?
How am I changing cosecant to cotangent? Oh, I guess. I guess we could. In the book, this is what they want as your final answer. Because, and I think their thinking is because you have 1s in there and stuff. So let's just leave it as is. Okay, but it was good looking out, because you could have 2 cotangent and the 1 in there. But let's just leave it as is, because the whole point of this really is to get this across. All right, just this one big step across. Okay, this is the last one, right? Yeah. Oh no, I got 2 more. Is that the same one? Yeah, that's the same one. All right, we are doing sine cubed x over sine cubed x minus sine x. I can't simplify that. Like, I can't change any of the signs to something else, so something cancels out. So what I want to look at is, it's kind of like looking at x cubed over x cubed minus x. We can factor out stuff with trig functions. So I can factor a sine out of that denominator. And how that would look is we would have this equals sine cubed x all over, I'm going to pull out a sine out of the bottom. I'm going to pull out sine x. We weren't using parentheses to start with, so why introduce them? That will give me sine squared x minus 1. Well, as soon as I do that, everything kind of falls into place. My sines will cancel out, and I'll just have sine squared on top, because that's like x cubed divided by x, which just gives you x. So we're going to have sine squared x all over. How can I rewrite sine squared x minus 1? Charlie?
Negative cosine.
Oh, awesome. Awesome. Awesome job. Who thought it was just regular cosine? No one? Yeah, I was going to say. I'm sure you're not the only one, Willie. Only one brave enough to say it. Do you see why it's negative cosine?
Well,
No? Okay. So this is one of the times where I say I have sine squared minus 1. So I have sine squared minus 1. I need to manipulate this formula, right? And my sine is positive, right? So my sine needs to stay here, so I need to move the 1 over here. But what do I have to do with the cosine then? Let's do it. Let's go ahead and do it. So if I subtracted 1 from both sides to get the 1 over here, I would have my, I would have my sine squared x minus 1, but I'd have that cosine still there. What do I have to do to both sides to get rid of that cosine?
Subtract the cosine.
I would have to subtract that cosine on both sides. And that would give me equals negative cosine squared x. So you do sometimes have to look at what you have and actually take pencil to paper. I know it's a brand new thing sometimes when we're trying to do it in our head. Just take pencil to paper and see what you get. And that's how you got the negative cosine squared. Impressive that you knew that. Most of the other class did cosine right off the bat. All right, so now I have negative sine over sine over cosine. Isn't that something I already know? Isn't that something? Yeah.
Wouldn't the answer be negative tangent squared x?
Negative tangent squared of x. Done. Questions? I think the big takeaway from today is these are last resort. This one isn't a last resort. This is a pretty quick, easy way to do it. The other two ways are kind of last resorts if I can't do anything else. But a bigger takeaway is if you have sine squared x minus 1, you're going to go to your sheet and see what has sine squared x and a 1 in it and manipulate it to make it look like sine squared x minus 1. Don't just automatically see sine squared and a 1 say it's cosine immediately.